So Google just expanded the Gemini API file search tool. And this update is actually bigger than the release post makes it sound. File search is now multimodal. You can drop images into the same store as your PDFs and documents, query everything in one call, and get back grounded answers with page level citations. If you have been building retrieval augmented generation systems by hand, this changes what the pipeline has to look like. Let me walk you through what they shipped, how the new multimodal retrieval actually works, and the three things you should know before you wire this into anything real. Now, quick context for anyone who missed the original release. File search is basically a built-in RAG or retrieval augmented generation system inside the Gemini API. You upload your documents, the API chunks them, embed them with Gemini embedding, and stores the vectors in something called file search store. At query time, you pass file underscore search as a tool. The model retrieves the relevant chunk, and the response comes back grounded with citations pointing to the original source. Before this update, the pipeline was text only. You could send PDF, code, markdown, logs, JSON, etc., which was useful, but the moment your documents had screenshots, diagrams, or scanned pages, you had to fall back to your own pipeline. Now, the announcement covers three things. One, it's multimodal. The store now embeds images and text in the same vector space using Gemini embedding too. So you can search both with a single query, results on the multimodal data and the text data. Two, now they introduce custom metadata. You can attach arbitrary key value labels to any document, like department equals legal or region equals EU, and filter retrieval against them at query time. The third is page level citation. The grounded responses now points to the specific page inside the source document, not just the document itself. Each of these matters on its own. Together, they close most of the gap between this and a hand-rolled retrieval stack. Most enterprise documents are not pure text. For example, insurance claims have photographs, engineering specs have schematics, medical reports have scans, and product catalogs usually contain images. Even a perfectly clean PDF of a research paper has figures that carry half the meaning. Now, before today, your option were extract text and lose figures, or run a separate vision pipeline and stitch results together, or pay for a multimodal embedding service and host your own vector store. None of these are great. With this update, you upload the document, the API embeds the visual content alongside the text, and query like show me the chart where revenue dipped actually retrieves the chart, not just a paragraph that mentions a chart. The pipeline has 5 stages. Stage 1 is ingest. You upload via the files API or pass the path directly. Stage 2 is chunking. The service splits the document into manageable units, in this case, text into token-bound chunks, images into discrete tiles or page regions. The third is embed. This is where the Gemini embedding 2 does the work. Both modalities go into the shared embedding space, which is the part that makes cross-modal search possible. Now, the fourth stage is the storing. A vector lands in your file search store, index for fast retrieval along with whatever metadata you attach. Fifth stage is query. You pass file underscore search as a tool on a generated content call. The model retrieves the top K chunks, optionally filtered by your metadata, and produce a grounded response with citations. Now, the thing I found genuinely interesting here is that the embed step now treats a screenshot the same way it treats a paragraph. This is pretty amazing. Now, the code shape is mostly the same as before, which is honestly the best part. If you already had a file search wired up, the new behavior just works. You're going to create the file search store, upload your files, and now those files can include images and PDFs that contain images. The image content gets embedded automatically. Now, to attach metadata, you can pass the custom metadata dictionary on upload. So for example, department email equals legal, or region equal EU. To query with a metadata filter, you set metadata filter on the file search tool config, something like metadata filter equals department equal quote legal quote. The response comes back with the grounded metadata, and inside that, each grounding chunks now exposes a page number field where applicable. So the migration from version 1 to multimodal is essentially nothing plus 2 optional fields when you want them. Okay, now on pricing, you pay the standard Gemini embedding rate at ingest time. Vector storage is free. Query time embeddings are free. Files cap at 100 megabytes each, and the free tier gives you 1 gigabyte of total storage. The original files stick around for 48 hours, which matters if you need to re-embed. Okay, in this section, we're going to look at the code, and I'll walk you through a few examples which shows different capabilities. We're going to be making use of the multimodal file search API. If you're interested in the text only, I have covered that in one of my previous video. So I'm going to show you how to do text query across PDFs with page level citations. Then we're going to do cross-modal queries. I'll also show you the metadata filtering, and then we're going to look at multi-source search questions answered across several papers. Now, you'll need to set your own Gemini API key. For this, I'm using older Gemini 2.5 Flash model, but you can use the latest model if you want. Now, the corpus that we have has two different things. One are the technical papers, so I uploaded Attention is All You Need and Vision Transformer paper. And then I created a few different plots which are not relevant to those papers, but they show the multimodal capabilities of this new file search API. So here we are downloading the papers. Also, if you look here, we are creating some metadata. So what is the modality, who are the authors, what year it was published, and what was the topic. For this one, again, we are doing something very similar. So right now you can see we downloaded both the files. And then in this section, I am creating multiple different plots. And the idea is that if you're using this multimodal file search from Gemini, you probably want to upload documents which are multimodal in nature. So I created this dummy data which shows the quarterly revenue for Q3. Then there is another one which shows the model accuracy over training time. And here's another one, which is a multimodal RAG system architecture, right? So these are just dummy documents to give you an idea of what type of documents you can include. Now I'm converting these into PDFs, but you can render them as images and store them as images. Okay, so the first thing is to create a store for storing the embeddings. Now we do a cleanup step, which basically if you rerun this notebook multiple times, I just want to make sure that we start fresh. So it's going to delete or remove the prior runs from the demo to keep things tidy. Okay, so after creating or selecting your store name, now we need to update or upload the documents to this store with the metadata that we created. Okay, one thing to point out for those images, I'm also including similar metadata, which is title, year, topic, and then modality. Now instead of paper, right now we're using chart as modality. All right, so here's how the upload works. We create the file search store. Then one by one, we're going to upload the documents and also include the metadata for each of the documents. So if you look here, we are putting these technical papers and the charts in PDF form, and we just show what type of modality they represent. Now, this is a simple helper function that is going to show what the grounding chunks are when we do retrieval. Now, let's look at the demos. So the first one is text query with page level citation. This is something new. This capability was not available in the prior release of Gemini file search, but now you can get page level citations. So here we are asking, how does a multi-head attention work, and why does it help over single head attention, right? So we just provide the file search name as a tool to the Gemini model, and here's the response. So this is the answer, but I am interested in what are the grounding chunks. So if you look here, it's mainly citing attention is all you need paper. It didn't go to the vision transformer paper. And you can also see page numbers. So page number 4, page number 3, then there's some discussion on page 7 and page 5. Now here we can actually go and look at so in the paper we can actually go and look at page 3. So it starts the discussion around attention. Now if you go down, this basically talks about multi-head attention. This is probably the chunk that it captured. Now on page 5, it continues, talks about embeddings and softmax. And page 7 is more of a technical details. Now, not all of these chunks are going to be relevant, but the model is smart enough to figure out what are the relevant chunks. And the main thing is that now it can tell you which page the information is coming from. Okay, so this second demo is cross-modal query. So we're asking, show me the chart where Q3 revenue dipped. What were the actual numbers? So if you remember, we had this revenue plot that I basically fabricated. So it has to retrieve this and then give us an interpretation of what exactly happened. So we see a drop from 168 million to 89 million for Q3. So here, we actually see that it retrieved the proper chunk as the first chunk. Then, interestingly enough, it also is looking at the page 22 on vision transformer paper and a couple of other, I think, not relevant documents. Now, this is just the retrieval step. You want your model to be smart enough to reason over chunks. So in this case, it's only creating answer based on the actual document that was retrieved. So it says the chart title query revenue 2025 illustrates dip in Q3, and then it's able to actually read those numbers, which is pretty good. Now here's another one, describe the system architecture diagram in our internal documents. Now think if you have some internal schematics for your business, you could potentially embed those and what are the components there and how they connect, right? So this basically looks at the multimodal RAG architecture that we have as a diagram. And interestingly enough, that since it's know about RAG, just by looking at that diagram, it can actually explain what exactly is going on. Again, the first one is the most relevant document. Then you have some irrelevant documents listed there that were returned by the retrieval mechanism, which is file search in this case. You probably want to have some sort of threshold below which you want to discard the documents if they are not, if they don't have enough similarity. But let's look at how do we do metadata based filtering. So my question in this case is, what architectural innovation does the vision transformer introduces versus CNN? And I only want to look at papers as modality in topics that are vision. Now, this is an example of enterprise use cases where you know the set of documents based on the metadata, or you might might want to look at documents from certain time range. You can use that as a metadata based filter and filter your documents based on the metadata, right? So in this case, it is only looking at the vision transformer paper and providing answer based on that. Now here is another example. What internal charts and diagrams do we have? Briefly describe each. We are limiting the modality to charts. This is going to filter the documents, and in this case we can see that these are the images that we generated, and based on that it's generating an answer. This is extremely powerful, and you definitely want to make use of this metadata based filtering. Now we can do multi-source research questions. So in this case we have two questions which are going to need two different papers that we have provided, right? So again, we are limiting it to modality equal to paper, but we are widening the retrieval for multi-paper synthesis, right? And for this to work, we actually need chunks from both of the papers. Now, turns out, I think it only retrieved information from the vision transformer paper, which is interesting, because I would expect that it would also look at the attention is all you need paper. However, since this paper actually uses information from the original attention is all you need paper, seems like it thinks that it has enough information based on that to actually propose an answer. You can also do something. You can actually look at grounding your answers, so you can inspect where did each chunk come from. So here I'm saying anywhere in the corpus where you see the word attention, list each source. We are limiting it to 10, right? But this is most probably, you can do something like this with keyword based search, but still the system is pretty smart enough that it is telling us the places where it sees the word attention. Okay, so just a quick recap on pricing. Each file is 100 megabytes. Free tier is 1 gigabytes of total of free storage. Vector storage is free. Query time, embeddings are free. You're only charged for ingestion of the documents, and during the generation you're going to be charged for all the tokens that you are using. Also, once you're done with your vector store, if you're not going to use it, it's better to just delete the vector store so you keep everything tidy. Link to this is going to be in the video description. Do let me know if you see use cases for this. I have been using the original Gemini file search API for some of my own projects, and I have found it to be really useful. And now with this multimodal capabilities, I think it's going to make it even more useful and powerful. Let me know how your experience with this new update is. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.